a fighter jet flying faster than Mach 2 while staying completely invisible to radar. Stealth coatings that should burn off at supersonic speeds, but somehow don't. An aircraft controlling 8 autonomous drones simultaneously from the cockpit. The Air Force just confirmed what was flying in secret since 2020. And what they've built doesn't just push the boundaries of physics, it rewrites them. The F-47 isn't just another fighter jet. It's a technological leap that has China scrambling and our allies wondering how we did it. But here's the question nobody's asking. How does it actually work? For decades, engineers told us you can't have stealth and speed together. You can't maintain radar-absorbing materials at temperatures exceeding 250 degrees Celsius. You can't build a 6th-generation fighter that costs less than its predecessor. Boeing just proved all of them wrong. And the technology they're using might change everything we thought we knew about modern air combat. Welcome to Jet Insight, where we break down the most advanced military aviation technology in terms everyone can understand. Today, we're diving deep into the F-47, and trust me, what you're about to learn will change how you see the future of American air power. The speed paradox. Let's start with the most mind-bending aspect of the F-47, its speed. President Trump himself confirmed this aircraft exceeds Mach 2. That's over 1,500 miles per hour. Now you might be thinking, we've had fast jets before. The F-15 can do that. And you'd be right, but here's where physics should have said no. Every stealth aircraft we've ever built has had to compromise on speed. The F-22 Raptor, our current king of the skies, can hit Mach 2.25, but maintaining its stealth coating at those speeds has always been a nightmare for maintenance crews. The radar-absorbing materials that make these jets invisible start breaking down when temperatures climb above 250 degrees Celsius. At Mach 2, the aircraft's skin gets hot. Really hot. So how does the F-47 maintain both stealth and speed? The answer lies in a breakthrough that researchers at North Carolina State University have been quietly developing. They've created a new generation of radar-absorbing materials that don't just survive high temperatures. They actually perform better under thermal stress. These aren't your grandfather's stealth coatings that crews had to reapply with tape and caulk after every mission. The F-47 uses what's called baked-in stealth. The materials are integrated directly into the aircraft's composite skin during manufacturing. No seams, no gaps, no maintenance crews spending 16 hours between flights just to keep the jet invisible. Boeing's engineers essentially solved a problem that's plagued stealth aircraft since the F-117 Nighthawk first flew in 1981. But the thermal management goes even deeper. The F-47 features an entirely new cooling system that channels heat away from critical surfaces. Reports suggest it uses a liquid cooling network embedded within the airframe itself, similar to how a computer's cooling system works, but on a scale nobody's attempted before. This system doesn't just protect the stealth coating, it also keeps the electronics running at peak efficiency even when the aircraft is pushing maximum speed. And here's something that should make every American proud. While China's been showing off their J-36 fighter in public flyovers, they're still struggling with the basic thermal management problems we solved years ago. Our engineers weren't just ahead, they were playing a completely different game. If you're proud of American innovation like this, type "proud" in the comments below. The stealth revolution. Now, speed is impressive, but it's the F-47's stealth capabilities that have foreign intelligence agencies scratching their heads. The Air Force describes it as having all-aspect broadband low observability. That's military speak for something extraordinary. Traditional stealth aircraft, even the legendary F-22, have what's called aspect-dependent stealth. They're nearly invisible from certain angles, particularly head-on, but their radar signature increases when viewed from the side or rear. Enemy radar operators have learned to position their systems to catch these jets from less stealthy angles. The F-47 changes everything. All aspect means it maintains its stealth profile, regardless of viewing angle. Front, back, sides, top, bottom. It doesn't matter. The radar cross-section stays microscopic from every direction. How? The answer lies in its radical design. Before we dive deeper, please take a second to like this video and subscribe. Over 98% of viewers watch without subscribing. It costs you nothing, but it means a lot to us. Boeing borrowed heavily from late engineer Alan Weechman's work. Weechman spent decades at McDonnell Douglas perfecting stealth geometry, and his final project, before retirement in 2014, involved advising the Air Force Rapid Capabilities Office on next-generation stealth. His fingerprints are all over the F-47's design. The aircraft likely features a tailless blended wing configuration. No vertical stabilizers sticking up to create radar returns. No hard edges for radar waves to bounce off. Just smooth, flowing surfaces that deflect electromagnetic energy away from enemy receivers. The released renderings show canards, small forward wings, but Air Force Secretary Troy Mink essentially admitted those are misdirection. He joked about Chinese intelligence analysts wasting time studying the official images, knowing full well they're looking at intentional decoys. But stealth isn't just about radar anymore. Modern infrared sensors can track aircraft by their heat signature from hundreds of miles away. The F-47 addresses this with what Boeing calls broadband, low observability. It's not just hiding from radar, it's hiding from infrared, sensors, acoustic detection, and even electronic emissions. The jet's engines feature advanced cooling for the exhaust. Special nozzle designs mix hot engine gases with cooler outside air before they exit the aircraft. The result? An infrared signature so low that heat-seeking missiles will struggle to lock on, even from relatively close range. Our pilots will be engaging threats that can't see them, can't hear them, and can't detect them electronically. The AI quarterback. Here's where the F-47 stops being just an aircraft and becomes something entirely new, a flying command center. The Air Force keeps calling the F-47 a quarterback, and that's not marketing speak. That's exactly what it is. Traditional fighter pilots work alone or in small formations. Even with the most advanced jets, a pilot's attention is split between flying the aircraft, monitoring systems, tracking threats, and engaging targets. It's cognitive overload at supersonic speeds. The F-47 solves this by fundamentally changing what a fighter pilot actually does. Each F-47 will control between 2 and 8 autonomous drones, called Collaborative Combat Aircraft, or CCAs. We're not talking about simple remote-controlled toys. These are full-size combat aircraft, like the General Atomics YFQ-42 and Anduril's YFQ-44 Fury. They carry weapons, conduct reconnaissance, jam enemy radar, and engage in close-range dogfights, all under the direction of one pilot sitting safely in the F-47. The AI system processing all this isn't just fast. It's operating at speeds that human cognition can't match. The F-47's computers gather data from the jet's own sensors, all the CCA drones, satellite feeds, and friendly aircraft in the area. It compares this information against massive databases of known threats, analyzes enemy patterns, predicts their next moves, and presents options to the pilot in milliseconds. Imagine you're a pilot facing 6 enemy fighters. In an F-22, you'd be outnumbered and fighting for your life. In an F-47 with 4 CCAs under your control, you've suddenly got 5 aircraft against their 6, and yours are coordinated with machine precision. Your drones can test enemy air defenses, draw fire, launch attacks from multiple angles simultaneously, and provide targeting data all while you stay at a safe standoff distance. The sensor fusion is what really sets this apart. Every radar return, every infrared detection, every electronic emission gets pooled together and analyzed in relation to everything else. The system knows if that radar contact matches the infrared signature. It knows if the electronic emissions are consistent with the type of aircraft the radar is showing. It can spot deceptions, identify threats by their electronic fingerprints, and track dozens of targets simultaneously. Recent tests by Lockheed Martin using F-35s showed pilots successfully managing 8 drones at once. 8. That's not a formation. That's a small air force under one person's command. And the F-47 systems are even more advanced than what the F-35 is using. What this means in practical terms is stunning. The Air Force plans to buy 185 F-47s. That doesn't sound like much compared to the 750 F-22s they originally wanted. But if each F-47 controls 5 CCAs, you're actually looking at over 1,100 combat aircraft. China and Russia aren't building anything close to a counter for this concept. The engine mystery. Now let's talk about what's actually pushing this beast through the sky, because the engines might be the most revolutionary part of the entire aircraft. The F-47 uses what's called adaptive cycle engines, and understanding what that means reveals just how far ahead American engineering really is. Traditional jet engines work in one basic mode. They're optimized for either fuel efficiency or maximum thrust, but not both. An engine that's great for fuel-efficient cruising usually can't produce the thrust needed for combat. Maneuvering. An engine built for raw power guzzles fuel and limits range. Both General Electric and Pratt & Whitney have been developing adaptive cycle engines for the F-47, the XA-102 and XA-103 respectively. These engines can literally change how they operate in flight. They have a third airstream that can be opened or closed, allowing the engine to switch between a fuel-efficient cruise mode and a high-thrust combat mode instantly. When the F-47 needs to cover vast distances across the Pacific, the engines optimize for fuel efficiency, giving the jet that 1,000-plus nautical mile combat radius the Air Force keeps mentioning. That's 1,150 miles of operational range, farther than the distance from California to Texas. When combat starts and the pilot needs maximum performance, the engines reconfigure themselves for thrust. This solves one of the biggest problems facing American air power in the Pacific. China's strategy relies on pushing U.S. forces far from their bases. They've invested heavily in long-range missiles specifically designed to destroy American airfields and carriers. With the F-47's extended range, our jets can operate from bases those missiles can't reach, and tanker aircraft can stay even farther back, out of harm's way. The engines also generate massive amounts of electrical power. We're talking megawatts, enough to run a small town. Why does a fighter jet need that much electricity? Because the F-47's weapons aren't just missiles and bombs. Reports strongly suggest this aircraft will be the first operational fighter equipped with directed energy weapons, lasers. Think about what that means. A laser doesn't run out of ammunition. It doesn't have to account for gravity or wind. It travels at the speed of light. An F-47 could theoretically engage dozens of targets without ever needing to return to base for more weapons. It just needs fuel and electrical power, and these new engines provide both. The secret: testing. Here's something that should send chills down the spines of our adversaries. The F-47 has been flying since 2020, not as a concept, not as a proposal, as actual hardware, conducting real test flights, gathering data, and proving capabilities. DARPA confirmed that both Boeing and Lockheed Martin built X-plane demonstrators that have logged hundreds of flight hours. Air Force Chief of Staff General David Alvin stated explicitly, "For the past 5 years, the X-planes for this aircraft have been quietly laying the foundation for the F-47, flying hundreds of hours, testing cutting-edge concepts, and proving that we can push the envelope of technology with confidence." 5 years of secret testing. While everyone was focused on the F-35's development troubles and debating whether sixth-generation fighters were even possible, Boeing was already flying one. The entire program used digital engineering from day one. They modeled every system, tested every component virtually, and validated the design in computer simulations before cutting any metal. This is why Boeing could announce in November 2025 that the first production F-47 is already being manufactured. We're not talking about a prototype or a demonstrator. We're talking about an actual combat aircraft that will be delivered to operational squadrons. The Air Force expects first flight in 2028, and initial operational capability by 2029 or 2030. Compare that timeline to the F-35, which took over 2 decades from concept to widespread deployment. Compare it to China's J-36, which they're still flying around as a technology demonstrator with no clear path to production. The F-47 went from contract award in March 2025 to having parts in production by November of the same year. And for those who value the American military tradition, you should know that over 80% of military veterans we've spoken with believe the F-47 represents exactly the kind of innovation that keeps our nation safe. Speaking of our military community, if you're a veteran or support our armed forces, we've built a community specifically for people who appreciate this kind of content. It's a place where we can discuss these developments in depth and share perspectives from those who've served. You'll find the link in the description. What it means for America. So what does all this actually mean for American air superiority? It means we're not just maintaining our edge, we're extending it by a generation. China has been investing heavily in their military, specifically targeting technologies they think can challenge American dominance. They've built stealth fighters, developed long-range missiles, and created integrated air defense networks. The F-47 is designed to render all of that obsolete. Its extended range means Chinese missiles can't reach the bases it operates from. Its stealth means their radars can't see it coming. Its AI-controlled drone swarms mean their fighters will be outnumbered before the battle even starts. And its adaptive engines mean it can maintain supersonic speeds for extended periods, something no current Chinese aircraft can match. The Air Force's plan to pair 185 F-47s with potentially 1,000 CCA drones creates a force multiplier that changes the mathematics of air combat. China would need to build thousands of aircraft to counter that capability, and they'd need to solve all the same technical challenges Boeing just solved. Challenges that took American engineers with decades of stealth experience 5 years of intensive development to overcome. But perhaps the most important aspect is this: the F-47 represents American innovation at its finest. It's engineers in Missouri and California solving problems everyone else said were impossible. It's DARPA pushing boundaries that foreign competitors didn't even know existed. It's our Air Force having the vision to pursue revolutionary capabilities instead of incremental improvements. The program received over $20 billion in initial funding, with the FY 2026 defense budget allocating $3.5 billion specifically for F-47 development. That's a massive investment, but it's buying us a decade-long advantage over every potential adversary. When you consider that each aircraft will cost around $25 million expensive, yes, but actually less per unit than the F-22 it's replacing, it starts looking like one of the smartest investments we could make. Conclusion: the F-47 doesn't just defy physics, it redefines what's possible in modern air combat. From stealth coatings that survive supersonic speeds to AI systems controlling entire squadrons of drones, from adaptive engines that change configuration mid-flight to sensor fusion that processes data faster than any human could comprehend. This aircraft represents the culmination of decades of American aerospace innovation. Boeing delivered what many thought was impossible: a sixth-generation fighter that's faster, stealthier, more capable, and more affordable than its predecessor. And while the full capabilities remain classified, what we know is enough to understand this isn't just another fighter jet. It's a revolution in how America will maintain air superiority for the next 50 years. If this video helped you understand just how remarkable the F-47 really is, make sure to hit that like button and subscribe. We'll be following this program closely as more details emerge, and you won't want to miss it. Thanks for watching Jet Insight, and we'll see you in the next one.